All right, so we're on day 6, block 2. So we just finished talking about congruent triangles, and now we're going to use that information to write some proofs. So these proofs, honestly, I think are a lot easier than some of the ones we've done in the past, and these would be kind of the main proofs of this course. So I think you guys will do a nice job here. We'll do a few together, and then you have one to do on your own. So let's just get started right away. So given triangle ABC is isosceles with vertex B, and BD bisects AC, we're trying to prove that triangle BAD is congruent to triangle BCD. So, as always with our proofs, we'll draw our T-chart, holding down the Shift key to make straight lines. And I'm going to start by writing down that given information. So I know that triangle ABC is isosceles, and I know that BD bisects AC, and that's given. Sorry, here on the left are our statements, and the right side are the reasons. Okay, so always same thing for step 1. Now, using that given information, let's start to label some things on our picture based on what that means. The vertex is very important for the isosceles triangle. So if the vertex is up here, that means that these are two congruent sides. Okay, the sides coming like off of the vertex. So I'm just going to say that next because I feel like that's probably going to be helpful as we're trying to prove these two triangles congruent. So I can say side AB is congruent to side BC. And the reason there, we're just going to say that's the definition, abbreviating definition of isosceles. We can just leave it nice and simple. I also know that BD bisects AC. So that's saying this middle segment here is bisecting the base. Okay, AC is the base. So bisecting means it's cutting it in half. So I label my picture first, and then I can say, okay, well, that means AD is congruent to DC, and the reason is the definition of bisect, because it cuts it into two equal parts. Okay, so now looking at my picture, I've used the given statements to say a couple things. So far I know that two sides of this triangle are congruent to the other two sides of the other triangle. I need one more piece of information in order to say that the triangles themselves are congruent. Remember, I can't just make things up. You do have a couple options here. Because this triangle is isosceles, you could use the angles if you want. But to me, I like the reflexive property a lot because it's so easy to use. The segment BD, both triangles share that, right? So if I highlight these triangles, so we have this one and this guy, both triangles use segment BD. So I put 3 tick marks there because I already used 1 and 2 to show that that middle side, you could say, is shared and congruent. And I know it seems silly, but we do have to put it in our proof that BD is congruent to BD, and we're just going to say reflexive. Okay, you have to have the pieces actually in the proof. We can't just assume anything. So now I have 3 congruent sides. So I can say that triangle BAD is congruent to triangle BCD, and our reason is triangle congruency side, 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 and you just have to write the abbreviation, as simple as that. Okay. Let's look at another one. All right, so again, we're writing a proof, so I'm going to start by making my T-chart. So here I have statements, and then reasons. Always going to start with that given information, so I know AD bisects BC, and BC bisects AD, and that's given. Okay, so using that, I'm trying to prove that triangle ABE, so that's this left side here, is congruent to triangle DCE. So that's the right side over there. So let's look at the bisect piece first. AD bisects BC. So here's AD bisects BC. So if AD is bisecting BC, that means BC is cut into two equal parts. So here and here. So I'll say BE is congruent to EC by the definition of bisect. I also have, seems like it's the same statement. It kind of is, BC bisecting AD. So because it's bisecting AD, that's the piece that's cut into two. So again, I'll say AE is congruent to ED for the definition of bisect again. Okay, so now I have two sides so far. I do need one more piece of information. So let's look at our picture. Now again, I can't just make things up. I can't just say that these angles in the corners are congruent because they look the same. Can't use that. But what I can say is that these middle angles are congruent. I'm going to put numbers on them to make my life a little bit easier. So number 1 over here, number 2 over there. That just makes the labeling easier, so feel free to do that as long as it's very, very clear in your picture which angles you're numbering. I can say that angle 1 is congruent to angle 2, and the reasoning here would be vertical angles. So we'll use vertical angles a lot throughout proofwriting, and we also use the reflexive property a lot. Those are kind of our two main ones. There's other things that we'll use, but those true if you're ever stuck, see if you can find vertical angles or a reflexive property somewhere. So now I look at my picture and I'm ready to say that the triangles are congruent because I have a side angles side congruency statement. So triangle ABE is congruent to triangle DCE. Always make sure your order matches what was typed. And the reason there is side angle side. I'm done. So we'll do one more together here, and then you have one to try on your own. Draw our T-chart. Statements, reasons. I'm going to start with the given information. So we know that triangle NMP is isosceles, and that MQ bisects angle NMP, and that's given. Looking at the triangles, we want to show congruent, NMQ, so like the left triangle, PMQ, and the right triangle. Okay, so just one thing to point out with proofs, you don't have to like know all the steps at the beginning, right? Like we talked about with proofwriting at the beginning of the course, you just do it piece by piece. Write one statement and see where that gets you. So I'm going to start with the fact that this triangle is isosceles, and I know the vertex is M. So again, that tells me right away that these two sides are congruent, kind of like that first one we did. And M is congruent to PM, and that's the definition of isosceles. And then I'm told that MQ bisects angle NMP. So MQ is the segment here, and it's bisecting the vertex angle. NMP, yep, that's our vertex. So that means that these little guys are congruent. I'm going to number them, 1 and 2. Angle 1 is congruent to angle 2 by the definition of bisect, right? Bisect means cut into two equal parts. Okay, so now when I look at this, I have a side and angle, and this is where I need to use my geometry reasoning. What else can I say is congruent? You have options again. If it's an isosceles triangle, you can say that these base angles are congruent. Or what I like to do instead, I like to use the reflexive property and say that this middle side is congruent. So I'm going to write that. It would be totally correct to use angle side angle though. So MQ is congruent to MQ, and that's the reflexive. So now I have triangle NMQ congruent to triangle PMQ, And my reasoning, because I'm using the reflexive, would be side, angle, side. Okay, so make sure you're using the correct statement based on what you've said previously. Okay, so you have one to try on your own. See if you can do this. One's very similar to the other ones we've done. Labeling your picture is really, really helpful, so make sure you're doing that as you start to build your proof. All right, so here's my final proof. One thing to point out, if your numbers, like if you numbered the angles a little bit different than mine, that's fine, as long as I can see it very clearly in your picture which angle you're numbering. Otherwise, you should be using the 3 letters to distinguish those angles. But if you want to shorten it, use numbers. One thing you cannot write, like for example, in this proof, I can't say something like angle L is congruent, angle L is congruent to angle S, because I have no idea which angle L that means. So we can't say anything like that here. So I basically did a similar process as before, using my definition of bisecting, and then I used the reflexive property for side LS, and I said they're congruent by angle, side, angle.